Hello, welcome to today's lesson on section 5.4, which is about factoring and solving polynomial equations. So a lot of this should be reviewed, but some things are a little bit different, and you'll see what I mean by that. So I'm just going to get right to it. And we're going to do 3 examples today. So example number 1 will be to factor x cubed plus 2x squared minus 15x. So this we've done before. You should know how to do this. Pull out the x. And then you do your little diamond, negative 15 and 2. 5 and negative 3. And because the leading coefficient of your quadratic term is now 1, because you just have plain old x squared, you get that. Pretty easy, right? So can I just review? Let's look at another one. Number 2, let's say I ask you to factor the following. 2y to the 5th minus 18y cubed. And of course, if you haven't noticed, we're dealing with polynomial expressions and equations. So in this case, you want to find the common term again, which is 2y cubed. You get y squared minus 9. Am I done? I'm not. You got to keep going. That represents a difference of 2 squares. Because y squared and 9 perfect squares, so you could break it up like that. So that would be the final answer, because we want to factor completely. So I probably should rephrase my instructions. Factor completely. Factor completely. Right, let's move on to number 3. Again, factor completely 4x to the 4th minus 16x cubed plus 16x squared. So you'll see in this case, I can pull out a 4 and x squared. And I'm stuck with this. But am I done? No. Do the diamond. You have negative 4 up top, 4 down below. Breaks apart as negative 2, negative 2. So we're actually going to have 2 binomials that are identical, so we could probably express our answer more compactly, like this. So that's number 3. Okay, now we're getting some weird stuff. Because 1 through 3 are all review. Again, we want to factor completely. Let's say we had the following. 16x to the 5th power plus 250x squared. We could tell that each of these are divisible by 2, and there's an x squared. So I pull out 2x squared, I get 8x cubed plus 125. Now one would think that he or she is done with this problem. However, that's factorable. And I'll explain why. There's something called the sum of 2 cubes. And it's a little formula that I'll ask you to memorize. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So notice how 8x cubed is like a cubed, and 125 is like b cubed. These are perfect cubes. So that means that a is going to equal 2x, and b is going to equal 5. We get this from cube rooting. So when we plug into the formula, ax cubed plus 125, notice how I'm going to make it look just like this. I'm plugging in 2x for a, 5 for b. Of course, I have to square the 2x. Minus 2x times 5 plus 5 squared. So when I work it all out, 2x plus 5, 4x squared minus 10x plus 25. Well, that's not quite the final answer, but that's what 8x cubed plus 125 is. So going back, we had 2x squared times 8x cubed plus 125. It's actually going to be 2x squared, 2x plus 5, 4x squared minus 10x plus 25. That'll be your final answer. And by the way, this huge chunk here is never factorable. That's why 4x squared minus 10x plus 25 stays the way it is. That's called the sum of two cubes. There's also a difference of two cubes. It's not that much different than the sum of two cubes. It goes like the following. A cubed minus b cubed equals a minus b, a squared plus ab plus b squared. So you got to figure out what a and b are. So you're probably asking yourself, do I have to memorize this as well? The answer is yes and no. You really should memorize it because you're going to have to do this again in pre-cal and in AP Calculus. But I'll make a deal. If Stanford beats Oregon this Saturday, I won't expect to memorize it for our test, which will be on Monday, November 21st, so 2 weeks from today. So root for Stanford. I'll give it to you, just have to know how to use it. And of course, you get a chance to practice this in class when we meet during block number 1 of this week. Okay, let's keep moving. Number 5. Again, factor completely. And here we go. X cubed minus 3x squared minus 16x plus 48. If you recognize this, there's 4 terms, right? Whenever you see 4 terms, try factor by grouping. We talked about this a while ago. So we have x cubed minus 3x squared minus 16x plus 48. Let's make it plus negative 16x. And remember, you have to have a plus in the middle when you do factor by grouping. You can factor out x squared, x minus 3, factor out negative 16. Oh, look at that. Those x minus 3's are the same. Pull it out. You're stuck with x squared minus 16. We're still not out of the woods yet, because x squared minus 16 does represent the difference of 2 squares. Like I mentioned, all the way up here in number 2. We have y squared minus 9. So the difference means minus, and both terms are perfect squares, so we can break it up into 2 separate binomials, x minus 4 and x plus 4. So that's number 5. Okay, let's try some more. I know it's a lot, but I really want to kind of get through this. Number 6, let's factor that one completely. And hopefully you're taking good notes on this, because you want to have these notes available when you're doing the classwork. Otherwise, it's going to be kind of difficult to get through all this. So if we think about it, this one is, it's like difference of two squares. Why do I say that? There's a minus, and 60 and 81 are perfect squares. So I could break up this like this. Now, there's no such thing as sum of two squares, but there is a difference of two squares. So I can break up 4x squared minus 9 again. So that's factored completely. Let's try another one. That's also kind of weird. Factor completely 2x to the 8th power plus 10x to the 5th power plus 12x squared. If you think about it, I probably could pull out a 2x squared, that's common among all three terms, plus 5x cubed plus 6. Now you think to yourself, okay, am I done? Actually, you could factor this. That's factorable. And here's why. What if you had a squared plus 5a plus 6? Notice I kept the same coefficients. That would be easy, right? You just know it's a and a plus 2 plus 3. Well, instead of a squared, now you got x is 6. Instead of a, you got x cubed. So now what I can do, oh, that just vanished. That's so cool. Anyway, now what I can do is break up part x6 is x3. Because x3 times x3 is x6. Remember we talked about this when we did rules of exponents about 2 weeks ago? Plus 2 plus 3. That gets you the same thing because when you FOIL it, you do get 5x cubed and 2 times 3 is 6. And of course bring your 2x squared down. So that's to get for that one. And we can't really do sum of cubes because 2 and 3 are not perfect cubes. Okay, last one. I'm sure you're probably sick of factoring by now. I'm kind of sick of it too, but last one. We got to solve one equation. Let's solve the following. So remember what I've always said when you're trying to solve? Get everything on the same side, so you have 0 on the other side. Then we'll factor. Pull out a 3x. So you have x4 minus 6x squared plus 5. You can factor even further. Now x4 breaks apart as x squared. And so x squared is kind of like your linear term if you want to think of it that way. Minus 5 minus 1. Break it down even a little bit more. Because x squared minus 1 is x minus 1 times x plus 1. And then you can get 4 answers. You get 0. Actually, sorry, you get 5 answers. Plus or minus root 5. 1. And negative 1. And the reason we get 5 answers is because we had degree 5, so we do expect 5 answers. So those are your answers right there. So that pretty much concludes the video. There'll be some questions I'd like you to answer. Basically, I'll ask you to factor one problem and also solve one. And I think that's fair. And I'll see you guys Tuesday for periods BEF or Wednesday for G period. Okay, goodbye.